Hey guys, I recently picked up a 16 gig compact flash card on eBay, and as per usual, it had been erased by the previous owner. They deleted the partition, created a DOS partition, and formatted it for DOS. But I was curious to see what sort of information I might be able to restore from it. So I used FreeBSD and a copy of test disk, and I was actually able to restore a rather disturbing amount of sensitive information. Now, of course, I immediately deleted that info, and I'm not going to be showing any of that on the channel, but I would like to talk about the procedure that I used to restore this information. Now, I have a 512 meg compact flash card that I've used in a previous project. I'm going to install that in my FreeBSD system, ELSA, and we're going to restore the information from that card. And then we'll analyze that information and see what we can determine about the server that it was in. So loading into FreeBSD 14.3, I'll do a gpart show. And you can see we have two hard drives, or to be more accurate, we have two compact flash cards. I'm booting from an 8 gig compact flash. That's ADA0. And we're going to be restoring from the 512 meg ADA1. But I don't want to work directly with the compact flash card. Let's actually take a backup copy of it first. Now I'm going to use the dd command. We'll dd the dev ADA1 device into a file called cf512 blank.img. This way we have that compact flash card as a backup in case we do anything wrong with the image. Now, if I were working directly with the compact flash card, I would issue a test disk on the dev ADA1 device. But since we're working with a disk image, I'll use test disk cf512 blank.img. Chances are we have an Intel PC partitioning scheme on the disk. So let's select that. We'll do an analyze. And right away, of course, the program finds our FAT16 DOS partition. But let's do a deeper search and see what else we can find. If I do a deeper search, right away it finds a Linux partition running from cylinder 66 to the end of the drive at cylinder 992. So I'm going to restore that back to the image. And after this, test disk is going to tell us that we need to reboot the system. Now, in my experience, that's probably not necessary, but I'm actually going to shut down the computer just in case. We'll remove that compact flash card, and that way there's no chance that we could inadvertently overwrite some data. So we're back up and running, and since we've modified that disk image, I'm going to rename it to CF512 restored, just to indicate that we've restored some data to it. It would actually have been a good idea if I had the space to make a backup copy of that disk image. And now that we have a restored partition, we need to mount that under Unix so that it's accessible. If you're not familiar with Linux and Unix, mounting a partition essentially means attaching it to the root file system to give you access to it. So we're going to mount it under /mnt, and then we'll cd into that directory. As you can see, we have an ext2 file system mounted under mnt. If I cd into that directory and do a file listing, we do indeed have a Linux file system hierarchy. So let's cd into the etc directory and see what we can find out about this server. So down at the bottom, we have a file called Red Hat Release. So we know this was indeed a Red Hat server. If we cat that file, specifically it shows this was Red Hat 6.2, so obviously an older system. We can cat the etc hostname file and see that this server was called Scarlet. And the etc hosts file reveals a lot more information. Not only do we have the IP address of this host, but we also see the IP addresses of a lot of other servers within her little network. Now these are all RFC 1918 C block IP addresses, so they're not real world accessible. But hypothetically, if they were, we now know the host name and IP address of a whole bunch of servers. That's not necessarily information that you want released to the outside world. We also know that Jasmine was a mail server. You can see the POP3 and SMTP in that host file for Jasmine. The etc password file reveals even more information. Now, of course, this file does not contain the passwords, ironically, but it does contain a list of valid users that were on this server. You see a lot of familiar names there: Scott, Annika, and Philip. Now, I hear a lot of you saying this was a decommissioned server, so how could this information possibly be useful? Well, what if this system was taken down for a major hardware upgrade? It could have been replaced by a newer version of itself, and all of those users were recreated on the new version of the server. We also have the etc shadow file. That contains all of the encrypted passwords for the users on the system. Specifically, those are hash strings. Now, there are tools out there like John the Ripper and Hashcat that may be able to brute force some of those passwords. So you think about it, we have the IP address of the server, we have the host name, we have a list of potentially valid users on the server, and we may even have their passwords. So this is very sensitive information that really should not have been released. Now, if we cd back into the MNT directory, we can go into home, and that contains all of the users' home directories. Let's pop into Annika, and we'll take a look. She appears to have a dead letter file. She must have tried to send an email, something went wrong, and the system just saved a draft copy. If I open that file, now we have a couple of email addresses. There's Scott at jasmine.local and Annika at jasmine.local. That information could be very handy for social engineering purposes, or at the very least, we could send them some spam. Now, I'm not going to delve too deep into the user's home directories. There could be a lot more sensitive information in there. So last, let's take a look at the system logs. I'll cd back down into the var directory. We'll go into log, and let's open up the messages file. In the messages file, you can see this was a Pentium 3, 500 megahertz, and it had 256 megs of memory. There's probably a lot of additional useful information in there. And of course, we've really only scratched the surface on the information that we could recover from this server. So now the question becomes, how do we safely delete information when you want to offload a hard drive? Well, I'm going to use the dev urandom device under FreeBSD, and we're going to use the dd command to write dev urandom to that hard drive, or compact flash, I should say. That's going to write random data over that entire drive. This alone will make it very difficult to restore any existing partitions. Now, if you wanted to be absolutely safe, you can use a government wipe program that'll overwrite the drive with various patterns and run it multiple times. So will any of this guarantee that you can't restore information from that drive? Unfortunately, no. The only way to be truly sure is to physically destroy the drive. A lot of financial institutions will do exactly that. They take a power drill and poke a bunch of holes in the drive, or they'll actually feed them into an industrial shredder. But short of that, using the dd command and dev urandom will make it very difficult for anyone to restore information from your drive if you have to sell it. So if you enjoyed this one, please feel free to like and subscribe, drop a comment down below, and as always, thanks for watching.